All right, we're just going to finish off 10.3 with the last couple examples here. So we've got this situation here in the diagram. It tells us a bunch of information. It looks like they've put it all on there. AB is tangent. Notice that this one, it says AB is tangent at point B. Normally what we've seen is that that line keeps going, but it doesn't have to. You could just have this line. So if it's tangent at point B, that gives us a 90-degree angle there. BD is the diameter, AB is 7, that's told us, AD is 25, and this is an equilateral triangle, which it shows us based on that. Okay, so what's the length of the diameter? Okay, so this is a typical Pythagorean theorem question. We've got a right angle, we've got 25, and we've got 7, so we can actually figure that out right here. So x is, we're missing the leg, so it's going to be 25 squared minus 7 squared. Okay, let's quickly jot that one in. 25 squared minus 7 squared. So it gives me 24. Now, I'm not going to put 24 because things are getting confusing. I've got other lines coming off there. I know the whole diameter is 24, but what's this? This is the radius, so it's going to be half. So that means this part's 12, this part's 12, this part's 12, and this part's 12. So we could actually put another tick there. All of those pieces are 12. Okay, so what's the length of BD? That was 24. What's the length of BE? That's 12, because it's the same as the radius. Okay. What is the measure of the inscribed angle BED? So B to E to D. Now, this is actually going back to 10.1, where we learned something. If I just look at this, and I just look at that point and that point, remember what we talked about with arcs, this is actually, right here, a central angle, and coming from, subtended from the same arc, we've actually got a 90-degree angle, because this will have to be 180, this will have to be half. So it's kind of bringing a little bit of all the rules kind of together. So that means that's a 90-degree angle. Okay? And so because I know that's a 90-degree angle, I can actually create another triangle here. Just take it out, because I like to keep things separate. This side is 24, this side is 12, and so we could actually figure that out using the Pythagorean theorem as well. Okay, that's what we're asked for. So y is equal to the square root of 24 squared minus 12 squared. Okay, if you're careful, you can plug that whole thing in. Square root of 24 squared minus 12 squared. Okay, that gives you 20.78. I usually go to 2 decimal places. So it's your answer to the nearest millimeter, so it'd be 21 if you were asked. 21 millimeters. Okay, so using this kind of isolated, I think this is a nice strategy to take that triangle out just and do your work on the side, just to keep things neat and organized. Helps you to solve some of that stuff. Okay, show you know. Similar situation here. We're told a bunch of information. We're told this is tangent. QR is the diameter again, which means that's a 90-degree angle. That's 9, that's 41. What's the length of the diameter Q to R? So we actually got pretty much the exact same situation here. Right, this is 9, and this is 41. So we could solve for x doing 41 squared minus 9 squared. Okay, so we'll run through that quick. 41 squared minus 9 squared gives you 40. Okay, so that means the diameter is 40. Okay, but again, it's not going to really be useful for me to write that all and make a big mess out of things. I'm going to use these distances, 20, 20, and 20. Okay, because the radius, so QS is also 20. Okay, what is the length of chord RS? So that's this distance. So again, we can create another right angle triangle off of that. Okay, because we know, just like in the last example, that's 180, which means that has to be 90. So that's going to be my 90. This is what I'm looking for. This is 40, and this is 20. So I can solve for y by doing 40 squared minus 20 squared, taking the square root of that. Okay, so we'll move through that. 40 squared minus 20 squared. Okay, so that gives me 34.64. Okay. What is the length of chord RS? That's what we did. Here's what we did. Okay, last example with the show you know as well. Solve problems with tangents. So, speed skater's practicing on a circular track for some reason with a radius of 40. He falls and slides off the track. So you know if you fall on the ice, you lose your grip, you lose your balance, you go flying. You don't keep turning in a straight line. You're going to run tangent to the circle. He slides for 22 meters from the point that he fell. So the point that he fell is going to be tangent to the middle of the circle. Okay, how far is he from the center of the rink? So if we know this and this is a simple Pythagorean theorem. Okay, 40 squared plus 22 squared. Okay, so square root of 40 squared plus 22 squared gives you about 45.65. Okay, how far is he from the center of the rink? He is now 45 meters. Alright, so some problem solving questions you may have to actually draw out the situation, like this example here. Callan's attempting to land his model airplane when the wire breaks just before touchdown. If the length of the control wire is 10 meters, so we know that this is 10, kind of a similar situation, and the plane stops at a location 74, so obviously when it stops it's going to shoot out this way, okay? Length of the control wire is 10 meters, so he actually flew for a long way, because now this is 74, stops at a location 74, so assuming he's standing here, this is actually 74, so this picture is obviously like kind of out to lunch, right? But doesn't matter, we can still do the math behind it. It says how far does a plane travel after the wire breaks? So broke here, lands over here. So you've got this situation. Again, the picture doesn't need to be perfect because the 74 and 10 doesn't seem to line up, but we can still do the math behind it. 74 squared minus 10 squared. Okay, so if we do that, we should be able to find the answer. Gives you 73.32. Okay, so travel quite a ways. So this picture would actually be way further that way. Okay, so there's tangents to a circle. We finished off. You have a few questions to practice on 399.